Hello, I'm Stalnaker back for our next conversation on the 1.5 imperative. We have a full room here, so if I could just grab your guys' attention from around the various corners of the Ice House. We're back live on Facebook, so hey guys, welcome back. We're actually doing a 3-hour session this year on the 1.5 imperative, so you can tune in to a number of different clips with conversations from people who are here in Davos, who are essentially experts on this subject. So we have a full room here and a great audience. Joining me now is Pam Pearson from the International Cryosphere Climate Initiative. That's a lot to get out of one mouth. International Cryosphere Climate Initiative. Let's have a seat and talk about what that means. You guys are kind of experts on this idea of the 1.5 imperative. So tell us a little about what you guys do.
Well, we sort of started right after Copenhagen, actually, and it was because cryosphere scientists, and cryosphere, again, are snow and ice regions around the world. It's a word that a lot of people don't know what it means, and it's really important. It needs to be as well known as the atmosphere, because really life depends on having a healthy cryosphere. For the entire time that we've had civilization, there have been massive amounts of ice at the poles. That is really the world's refrigerator. You have glaciers that provide water, snow that provides water. All of these things are really important. And so we, I'm an ex-climate negotiator, a diplomat, but also the cryosphere scientists, just like Julianne was talking about just before, about when it gets personal. For cryosphere scientists, this is very personal because they're seeing changes that they never thought they would see in their lifetimes. And they are so alarmed. And I know scientists who say back in 2005 or even 2010 were very conservative about what they wanted to say, and they're becoming so alarmed that they really want to speak to policymakers. And so for that reason, we put out a report about thresholds in the cryosphere system just before the Paris Agreement, the Paris COP. And for now, for 2020, in this period, when countries are deciding what their nationally determined contributions, what their climate commitments are going to be, stakeholders, businesses are deciding this. We've put out a report first in Madrid, and now we have a briefing for executives that we're putting out here that is really short, but it's talking about why these physical limits are so important this year. And the highlights, I'll go back on some of the things you were talking about. So permafrost, for example, once it thaws, it's not all at once. It keeps emitting carbon for 2 to 3 centuries afterwards. So we can see traces of thaws today of what happened 200 or 300 years ago. So what that means is that if we allow permafrost to thaw, even today, we need to have negative carbon emissions to offset that. And I agree, a real shout out to those of you working in agriculture. We actually work in that too. We're trying to help farmers stop burning because a lot of farmers still burn around the world. That releases black carbon. That speeds the warming. If you do no burn agriculture, regenerative agriculture, you're fixing carbon instead. So that's a solution right there. So permafrost needs to be thought of something where the main way to stop it is just to keep temperatures down. And it indeed needs to be taken into account. Arctic sea ice, there's a lot of talk about coral reefs right now. You need to start thinking about Arctic sea ice. It's like a coral reef, this thick multi-year ice. If you look at it from the bottom, it's green. It is a very living ecosystem, and the entire ecosystem up there depends on having this thick multi-year ice. It's
Are there organisms living on the ice?
There are plenty of organisms living, yeah. I usually have a PowerPoint, so I'm kind of out of my depth right now, but I have a wonderful picture of this green, thick ice with fish in it. It looks like a coral reef. That's why that multi-year ice is so important, and it is essentially gone right now. We used to have ice that was even 7 to 10 years old. Less than 2% of the ice now is more than 3 years old.
Is that in the Arctic?
That's in the Arctic, yeah.
Wow, so that's even worse.
It's even
this
worse.
Conversation is always like...
The conversation gets worse than that because there's a big focus. There was some talk about, when is the sea ice going to disappear? And I'm trying to get the sea ice scientists to stop giving those kinds of projections because here again, it's all about temperature. And what sea ice scientists know, and this is one of our highlights that will come out in the next IPCC report, is that even at 1.5 degrees, we're going to have the occasional summer without summer sea ice. Maybe for a few days or a couple of weeks in September, which is the minimum every year. But by 1.7 degrees, that's when it's going to be gone for some period every summer. And by 2 degrees, it's going to be ice-free between July and October most years. And you may have shipping industries saying, wow, that's wonderful. It's not wonderful, because then you get all of these feedbacks that you were talking about.
Yeah, so what does that do to the jet stream, like the North American jet stream, if there's no sea ice? That seems like a very, you said before, that amazed me when you said that humanity has never existed without polar ice.
Right.
And we're about to be the first generation without polar ice.
Yeah, that's going to be difficult to avoid. And we're seeing perturbations in the jet stream. That's actually one of the more controversial findings. But I think more and more scientists are convinced that what we're seeing, say right now here, there's not.
We're calling it summer Davos.
Yeah. This is really warm. I live in southern Sweden. We haven't had any snow. It's been constantly above freezing. At the same time, where my son lives in Minnesota, they just got a big dump of snow. It's really cold there. And what you're getting is instability in the jet stream. And so you're getting periods of time where it is really cold, usually in North America, or really cold in Europe, but not both at the same time. And at that time, it's really warm in the Arctic. And so you're getting Alaska. Actually, parts of Alaska for the first time last year had temperatures above 0 degrees. In other words, their annual mean temperature was actually above the freezing point.
Has that ever happened?
No, not in the history of temperature that we have. So the other feedbacks from loss of sea ice, a paper came out just last week associating permafrost loss with sea ice almost being more closely related to how much sea ice there is than temperature. And so you get that feedback. You get more Greenland melt at that point. And a really important thing to understand is in Earth's history and with these ice ages that everybody knows about, CO2 actually fluctuated between about 180 ppm and 280 ppm, almost like clockwork. And then that together with orbital perturbations led to ice ages. So you can see at 415 how far we are out of that 280, which is that's about pre-industrial. And we were at about 295 in around 1880. So just in the space of a couple of generations, we've gone from 295 to 415. And one of our ice sheet scientists talks about, that was my grandmother's birth.
Can you talk for a second about, I think there are people in the world who are not climate experts. I'm one of them. And, if I talk to my mom about climate change, and I say, Mom, 150 parts per million, or 350 parts per million, or 415 parts per million, it really means nothing. And I think that some of the skepticism from like an average person, it's a little bit simple, but it's just like, how do you measure? How do you figure out how much carbon is in the atmosphere? Like, can you just give us a quick, 1 minute stand dummy explanation of how do we know exactly how much carbon is in the atmosphere? How is it being measured? Is this talk for a second about the provable science, so that an average person can understand how serious this is.
Well, parts per million, I'm not a scientist, I'm an ex-diplomat, so exactly how it's measured, I really can't say. Maybe your next speaker is
We'll get a scientist up here.
Yeah, get into that.
Okay, we'll get one up.
But it is one of the reasons people talk about CO2 is it is very easily measurable, and every single day, actually, you can go online and find out what the part per million are that day. It fluctuates based on breathing in and out. Summer and winter is mostly in the northern hemisphere. So that's why you really need to talk about averages. So I checked a couple of days ago, and we were at 414, I believe.
Where can you, do you know where you can go to check that yourself?
You can go to, in the US, the NOAA website still is publishing things like that. There are several websites that keep track of that. Most of them go off, the oldest ones are at Mauna Loa in Hawaii, and that's where you get this Keeling Curve that you'll hear, say, Al Gore talk about all the time. That's been then measured. I think that's the longest continuous measurement of CO2.
And I think that's where I was trying to get to in that question, that comment, is this idea that there are stations, there are points in the planet where this has been measured for a long time, and we're able to compare the data day by day, going back now many years, where we can actually see the change in real data. Is that right?
And you can go into ice cores where air bubbles are trapped, and you can find out what it was in the past, and that's why we know there's this fluctuation between 180 and 280 for a very long period of time. And what's really, again, important with that is knowing how far outside of that norm we are right now. And that's why it is so urgent to, indeed, 450 is about 2 degrees. And one of the things that the climate science community is really well aware of this right now. People will talk about the sensitivity of the climate system to CO2, and it's been at a certain level for a long time. With the next IPCC report, they're probably going to come out and say sensitivity is greater. So we may be in even worse shape than we are right now.
Well, I hope we're going to be able to get into some solutions with you guys in a few minutes, because right now the science is looking pretty serious, right?
Yeah, it's very serious, but at the same time, the 1.5 degree report said, and this is definitely the case, that we have a physical possibility of staying under 1.5. We have the technological ability to stay under 1.5. We have the economic viability to stay under 1.5. We win if we stay under 1.5.
And it's possible?
Absolutely, it's possible.
Okay.
Yeah, the naysayers
I think our next speaker is going to tell us how we're going to do it, right?
Yeah, I mean, it really is possible. It's going to be a huge effort. But, you know, the doomsday, I mean, I'm not here to be a doomsday person. I'm here to be an urgency person. This is really important. This is really a crisis. It is like World War III, and we need to react like it is. But if we do, we can do this. We can absolutely do this. The only things missing are political will and social will. And if society says we think this is important enough to do it, and enough politicians agree, then we can do it. And between 2020 and 2030, without overshoot. That's something we're saying too.
Without overshoot.
Yes.
So co-creating the future society, it's up to us. Thank you, Pam.
Thank you for doing this.
Yeah, we'll see you online. And if people want to learn more about the initiative,
Go to icccinet.org. There is this briefing for executives, but then also a longer one. And again, this isn't my message or ICCI message. Believe the scientists. That's what the event at Basecamp is going to be. There are over 40 scientists that have signed on to this, most of them IPCC. This is really well-established science. This is nothing new to them, but it is new to your mother and to a lot of people here, I suspect.
well, I mean, it's not, because her house has been covered in smoke for 3 months in Oregon. So, you know, this is something that affects all of us. Thank you, Pam. Thank you. Okay, we're going to be back shortly with Carl Burkhardt from One Earth to explain a solution. How are we actually going to solve this kind of gigantic issue? We'll be back in a few minutes.